Why, hello there. Today we are going to be talking about using the discriminant to find the number of solutions to a quadratic equation. Now, before we get going, I should just emphasize the point that solutions are the same thing as x-intercepts, are the same thing as zeros, are the same thing as roots. So the discriminant can help us find out how many of each of those things there are if we are ever asked to find them. So without further ado, the discriminant is defined as the part of the quadratic formula under the square root. That's this thing over here, b squared minus 4ac. And it is the sign of this discriminant here that's going to tell us how many solutions we have. If the discriminant comes out positive, there are 2 solutions. And in the event that your discriminant equals 0, there is only 1 solution. And in the situation where your discriminant comes out to be a negative number, why, there are no solutions. The moral to the story is this. Find your a, b, and c values, plug them into the discriminant, and see the sign of your answer. You don't really care what the actual value is, just whether it's positive, 0, or negative. So why don't we take a look at a few examples below and get an idea of exactly what it is that we are working with. So, our task here is to use the discriminants of each of the following functions to determine the number of solutions that each function has. We'll start with f of x, because why not? Now, the first step in all of these is to identify a, b, and c, and a in this case is 3. b, the number in front of x, is 5, and c, our constant term, is equal to negative 4. Then we're going to plug these into our discriminant formula. That would be b squared minus 4ac, and we're looking for the sign at the end of the day. b was 5, a was 3, and c was negative 4. We go ahead and we evaluate this. 5 squared is 25. Negative 4 times 3 times negative 4 is positive 48. You put those two things together, you get 73. Now remember, we don't care that this is actually 73. We care that it's positive, because positive tells us that there are 2 solutions. Fast enough for you? Why don't we go ahead and take a look at another example. Taking a look at g of x here, we're first going to define our a, b, and our c values. A, the number in front of x squared, is equal to 1. B, the number in front of x, is negative 8. And c, our constant term, was 16. We're going to plug into b squared minus 4ac. We are again looking for the sign of our answer. B was negative 8. A was equal to 1, and c was 16. Now we go through and we evaluate this thing. Negative 8 squared is 64. Negative 4 times 1 times 16 is negative 64, and we get 0. 0 is a very specific answer, because if we get 0, we know that we have only 1 solution. Very nice. Let's do one more example. So you may be able to guess the answer to our last thing here, but don't get too far ahead. Let's go through the steps. A is equal to negative 2 this time. B, the number in front of x, is 1. And c, our constant, is negative 7. Plug into b squared minus 4ac. And we are going to get a b value of 1 squared, and then a was negative 2, c was negative 7. We go ahead and we evaluate this thing. 1 times 1 is indeed going to be 1. Negative 4, negative 2, negative 7 together is negative 56. Minus those things, and we get negative 55. Negative 55, and remember, whenever you have a negative answer, that means that there are no solutions to our quadratic equation. H of x has no x-intercepts. And remember, folks, that was the whole point of this endeavor from the start. We were trying to figure out how many x-intercepts each of our equations has. F of x passes through the x-axis twice. G of x kind of bounces off of the x-axis. And h of x, why, it never even reaches the x-axis. It hits its vertex, and then it goes off in whatever direction it was heading to begin with. So, once again, define your a, b, and c values, plug into b squared minus 4ac, and take a look at the sign of your answer. If it's positive, there are 2 solutions. If it's 0, there is 1 solution. And if it's negative, there are no solutions. Good luck, folks. See you next time.